Hi everyone. This video will use order of operations to remind you how to manipulate and solve math problems with fractions. This can be a refresher for those of you grade 9 and up. This can also be a review for those of you in grade 7 and 8, maybe preparing for your final exams, and also to help you with your homework. Now I invite you to first pause the video and try to solve the problem on your own. And when you're ready, let's get started. So here we have an equation. We have 2/15 plus 2 over 3 all to the power of 2 plus 3/5 divided by 1/2 minus 2 cubed all over the square root of 144 times 5/6. So we know that BEMDAS is brackets, exponents, multiplication and division, which can go either way, and addition and subtraction. So this is the order that we want to move along to solve this equation, even if everything in the equation is not written in this order. So we see brackets first. So let's look as to where we have our brackets. So far, I just see them in one place, which is really useful for our exponent over here, our square. So we're going to start right there. We also have an exponent here that we can tackle at the same time. So sliding down my paper, my super technical way, we know that 2/3 squared actually means 2 to the power of 2 all over 3 to the power of 2. So we know 2 times 2, or 2 squared, is 4, and 3 times 3, or 3 squared, is 9. So this here gives us 4 over 9. Over here, we have 2 cubed. So 2 cubed, we get 8, 2 times 2 times 2. And we know that the square root of 144 is 12. If you don't know that, no problem. A calculator can help you out. But by slowly practicing and playing with the basic multiplication tables from elementary school, you'll rebuild the knowledge that 12 times 12 is 144. I put this here for grade 9 plus. You'll know your radicals. So to show you that your square root does mean 144 to the power of 1/2. And that I just did that, grade 7 and 8, here to show you how this this square root also fits in to exponents. But don't worry about that. Now another fun thing here is we see our 8 over 12. Now we know that they're both divisible by 4, so we're going to go ahead and simplify that fraction so that it'll be easier to use throughout the rest of the problem. So we take our 8 divided by 4, we'll get 2 in the numerator. 12 divided by 4, we'll get 3 in the denominator. So all of this over here turned into a beautiful 2 over 3. Now let's keep going here. Next step in our order of operations in our BEMDAS are multiplication and division. Now if you look at the initial problem, they're not in brackets, but we would have to be able to identify that we want to do 3/5 divided by 1/2 before we do 4/9 plus 3/5. Same over here. We want to make sure that we do the multiplication before we attempt to subtract whatever's over here by whatever's over here. So order of operations, sometimes maybe the brackets will be given to you. Otherwise, you can put them in if that helps you. I know it helps me. So as we reviewed in our fractions, we've got a division, we've got a multiplication. We're going to review it again right now. So the procedure for division, I like to call it flip and switch. So here we go. We're going down. Don't worry about the other side for now. But see over here, I now have 3/5 times 2 over 1. Here it was a half and a division. So what we did is we flip the second fraction that we're given. So the 2 and the 1 change their position. And then we switch. That makes the division sign turn into a multiplication sign. So once again, flip whatever's behind the division sign and switch the multiplication sign. Now we're going to see in both of these cases that when we multiply, we do numerator times numerator, denominator times denominator. Now, before we go to the next step, let's look over here where we already have numerator times numerator, denominator times denominator. But we also see that if we did that, we can cross multiply. Well, we can actually cross divide. Because remember, this line means division. So what's 2 divided by 6? We get 1 over 3. In other words, you can actually cross simplify as well. Just like you can simplify something in the numerator with something in the denominator, the multiplication lets you do this beautiful thing of cross simplifying. Over here, we can't do that because we know this 2 is going to be next to the 3. So it won't work in terms of division, but it will work in terms of multiplication. Once you flip, if you see an opportunity to cross simplify, you can do so, and it'll make the numbers a lot easier to handle. So let's do our numerator times numerator, denominator times denominator in both of these cases. So 2 times 3 will get a 6. 5 times 1 will get a 5. So we'll have 6 over 5 over here. And here, look, again, we have our 1 times 5. So we'll get 5. And 3 times now it's a 3, we'll get 9. So if we scroll down over here, you'll see we have 6 over 5 and 5 over 9, but we cannot cross simplify these guys because they're separated by a minus sign. So bringing everything else down, oh, I went too far there. Here we go. Now we have our addition and subtraction, the last parts here of our BEMDAS. So let's combine our like terms. Let's combine here our like fractions and work those together first. So we see our 4/9 and our 5/9. So ninths, they have the same denominator of 9. So we can work with those together. And then we see we have our 2 over 15 that's been sitting patiently on the side, and our new 6 over 5. And we're thinking, well, I like multiplying by 5. I can see that 15 and 5 can share a common denominator. So we're going to do that. We're going to multiply the 5 by 3 so that denominator matches at 15, and anything we do to the denominator, we're going to go do to the numerator. So we're going to do 6 times 3 and we'll get an 18. So as you can see, we've multiplied by 3. We've combined our like terms, and now we can do some adding. So we see our 15 and 15. We can leave those alone. Let's look at the numerators. We'll get 2 plus 18. In other words, 2/15 plus 18/15. A little tongue twister over there to get 20 over 15, or 20/15, plus 4 over 9 minus 5 over 9. So we look at the 4 minus 5. We'll get a -1, or -1/9. So if I move the paper over here, we'll see that math work done. Oh, I went a little too far. It gave you a sneak peek to what's coming next. We look at the 15 and the 20 and we say, that also looks like something like fun to simplify. So we're going to divide the 20 by 5 and the 15 by 5. Why are we doing that? Is because that's how we're going to be simplifying over here fractions in general. Find something, the common, the lowest common multiple between the fractions, and simplify them down. So again, divided the numerator by 5, the denominator by 5, we get 4 over 3 minus 1 over 9. We're not done just yet. I promise we're almost there. As you can tell, once again, we need our common denominator. So what are we going to do to bring those common denominators together? They can unite and subtract from each other. Well, we say 3 and 9, lowest common multiples of 3. So we can leave this alone, but we want to multiply the denominator by 3, the numerator by 3. So we get 12 over 9. So if you can check that by simplifying 12 over 9, you get back here to 4 over 3. Finally, we're where we want to be. Common denominators, one final step in our equation. We have 12 over 9 minus 1 over 9. At the end of the day, that becomes 12 minus 1 all over 9. So we get 11 over 9. Phew. One more step to go is the simplifying step. 11 in the numerator is greater than the 9 in the denominator. when you have a numerator that's greater than the denominator, that is an improper fraction. So to simplify, we want to make it into a mixed fraction. So how many times does 9 go into 11? It goes in once. Now it's 11 minus 1 times 9. 1 times 9 is 9. So 11 minus 9, that's where you get the 2/9. This is called the remainder. So if you put 11 divided by 9 in a calculator, you'll get 1 decimal point, the remainder, which I can tell you is 2. So if you divide this in a calculator, you'll see a 1.22222, continuous with a line over one of the 2's, if you write it by hand. And if you just take the 2 divided by 9 and put that in the calculator, you'll get 0.222 continuous. So you can always check that there as well. So there you go, everyone. Order of operations to show you many ways to use your fractions. I hope this helped. Good luck with your homework and your endeavors with fractions.